Hello everyone, my name is Alan. So for some reason I cannot come to your company to present my project. So this is why I'm making this video. The project I did in Insight program is called Fall Free. It's an inpatient fall alarm system. Falls are most common type of incident happen in the hospital. It threatens the physical and mental health of patients. Also, it's very costly. According to data of CDC collected from people of age older than 60 years old. The falls cost them $15 billion in total and 70,000 US dollars by average. But for those very expensive incidents, falls are most preventable. Previous studies shows that old people are most vulnerable to fall when they're getting off the bed. The process of getting off bed can be comprised into 3 steps: laying on the bed, sitting on the bed, and getting off the bed. So this is the most dangerous step. If we can know the time point when people are sitting on the bed, we can call someone to help to avoid the risk of a fall in the future. This is how the system works. An elderly patient is doing activity wearing sensor, and the signal of sensor is processed by a predictive model to classify a sequence of status. When the system detects laying on the bed followed by sitting on the bed, alarm is triggered, and call a nurse to help the patient exit the bed under surveillance. The dataset I use is from UCI Machine Learning repository. There are 40 healthy people performing 4 kinds of activities: laying on the bed, sitting on the bed, walking, and sitting on the chair. I have 3 accelerometer readings from different directions, and I have a strength, phase, and frequency of the signal from the signal receiver. The dataset is very noisy and sparse time series data of a high dimension. And at each moment, the datasets are labeled as sitting on the bed, laying on the bed, sitting on the chair, and walking. So this is my workflow. First, I did some data cleaning to remove the isolated data point. And then I select a time window to analyze a piece of time series to account for the intercorrelation of the time series data. I only select data from the past. It's important to only use the data from the past, because if we use any data from future, it will cause a delay of the system. And I did some intensive feature engineering. For example, by the accelerations, I calculate the change of speed and the direction of movement. By the variance of signal, I evaluate the fluctuation of the signal. By observing the signal are more fluctuate just before the transition of different status, we know the fluctuation is a very strong indicator. I engineered 86 features out of the 6 features and use PCA to do dimension reduction and decorrelate these features. With the first 47 PC, I used this model and different validation technologies. XGBoost is the best performed method. So this is the result of XGBoost with the length of a time window equal to 2 seconds. I'm especially focused on these 2 classes, laying on the bed and sitting on the bed. And I focus on the recall of it. I'm focused on recall because I want to detect as many as possible potential falls. So this is how the web app looks like. This is a real-time updating table. We can select the patient name here, and it will show the activity and the warning message. So if sitting on bed is followed by laying on bed, there should produce some warning message. Here's some conclusion. So there was a research team analyzing the same data set for 3 years, and the 4 papers are published. My model beat their model by improving the F1 score of 0.07. The LAM system has a very high recall with a decent precision. Assuming 5% of faults happen during bad editing, this system can save $2.4 billion according to the CDC data over 2010. This is about me. I went to Nanjing University to study math. After that, I went to UC Davis to pursue a PhD degree of biostatistics. My research is on differential expression analysis of the next generation sequencing data. In free time, I like cooking, eating, and traveling. Thank you.